Exercise 4C, question 4. Okay, so we have been given a function and asked to express it in the form of a over 1 plus 2x plus b over 1 minus 3x. In other words, partial fractions. So let's start by writing it up. So I've got 1 plus 2x and 1 minus 3x on the bottom, and I'm splitting that up into a over 1 plus 2x plus b over 1 minus 3x. So standard practice from our partial fractions lesson, multiply through by the denominator, so on the left hand side. So I've got 12x minus 1, I'm going to multiply everything by the 1 plus 2x, 1 minus 3x brackets. So next to the a, that will leave 1 minus 3x, and next to b, that will leave 1 plus 2x. Okay, so let's think of what to substitute in. I am going to start with x equals a third, as that will get rid of the a term. Right, so if we put a third in, we will get 3 on the left-hand side and 5 thirds of b. So b equals 9 over 5. So the first one we've met in this exercise with fractional or rational a's and b's. Don't panic. Quick double check is always worth it, but this one does work, and we'll check it at the end if you're not sure. So x equals minus a half. Do not assume there'll always be integers, which will give me minus 7 on the left-hand side and 5 over 2a on the right-hand side. So a equals minus 14 over 5. Okay, so that was our answer question. It's asked us for the values of a and b. Okay, so find the values of a and b. It didn't ask us to express necessarily in that form, so I'm going to leave it as a equals and b equals. Find the series expansion of this one. So let's just summarize what we've got. Minus 14 over 5 was the a value. That was 1 plus 2x. I'm going to jump straight to it in index form. So instead of putting it underneath, I'm going to bring it up to the side, and I've got 9/5 of 1 minus 3x to the minus 1. So remember, whenever we're doing a binomial expansion, we write it in index form and we expand those. So let's start with 1 plus 2x to the minus 1. It does start with a 1. I've got minus 1 and I've got 2x to work with. So it starts with a 1, so I can just use my expansion. 1 plus nx plus n minus 1 over 2 factorial, or just 2x squared. Quick check. No, I need to go up to x squared, so that is perfect. If I multiply that out, I get 1 minus 2x plus 4x squared. Always a nice one, that one. Right, so let's do 1 minus 3x to the minus 1. So minus 1 is my power, minus 3x is my substitution. Please be careful, and it starts with a 1. So straight in, 1 plus nx. Being careful, of course, to put it all in a bracket, including that minus. n minus 1 over 2 factorial minus 3x squared. Chuck all that together, I am going to get 1 plus 3x plus 9x squared. So they've been nice with those expansions, integers there. Unfortunately, now we're going to have to put it all together. So I had minus 14 over 5 lots of the 1 plus 2x expansion, which is 1 minus 2x plus 4x squared, plus 9 over 5, 1 plus 3x plus 9x squared. Okay, so now I am going to work that out. Again, you can use your calculator at this point. Literally work out the constant, then the x terms, then the x squared, and you will end up with minus 1 plus 11x plus 5x squared. Use your calculator if I were you on that one. Okay, quick check back at the question. Did we need the valid for expansion? No, it just said simplify each term, so I am finished with -1 plus 11x plus 5x.